Today we're going to refresh and review volume, but first go ahead and complete this do now review. So hopefully for this you use your calculator and put the points from the scatter plot into your calculator. So in order to do that, if you forgot how, you should have gone to Stat, which is right below the delete sign. Hit enter for edit. Estimate your X values as best you can and put in L1, the list 1, and estimate as best you can the Y values and put in L2. The Y values for the most part are pretty easy because most of them are directly on the lines. So once you do that, you're going to hit Stat again. Go over to the right once for the Calc button. Hit number 4 for Lin Reg, and then hit enter. And hit enter again, and you should get your A value and B value, which is your M and your B. So you probably don't have the same as me, but mine is about 0.147 x minus, since it's a negative, 0.37. So this is my general equation, the line of best fit that fits the majority of the points. I'm wondering though how many miles he's gonna run or expect to run after an hour. So my time though, my X value is in minutes, so I don't want to put 1 in for X, I need to put 60 in for X. And when I do that, I get 8.45. So 9 is going to be the closest to that. Test taking strategy, A is definitely out. 0.2 miles is all the way down here, so that makes no sense. 12, I'm going to also cross off because that is much higher. That is essentially, this is where my last dot ran off or left off, and that's about 38. And that was at 6. So to get to 12 miles, that would essentially be doubling 38 minutes, which is well over 70 minutes. So again, my answer is 9. Alright, quick refresher and review of how to find volume of cylinders, cones, and spheres. So again, the volume of a cylinder formula is pi r squared. So to find, if we just have a very basic shape, all I need to do is plug it in. So pi, my radius again is halfway from the center to the outside, so I'm going to do 4 squared times my height of 10, plug it all into the calculator, and I get 502 point, I'm going to round to the nearest tenths place, so I'm going to do 0.7, and that's going to be inches cubed. Volume, remember, is measured in inches cubed. Right, for the cone, remember the cone is 1/3 of a cylinder, so I need to multiply 1/3 times pi times my radius. Now we have to be careful. If I'm given the line that goes all the way across, that is the diameter. So a radius is half of a diameter, so my radius is going to be 9. 9 squared times my height of 21. Plug it all into the calculator. And again, I'm going to round to the nearest tenth, so it's going to be 1,781.3 units cubed. And my last one is a sphere. So this is the kind of weirder formula. So I have 4/3 pi r. My radius is 14, and this one's different. We're not squaring it, we're cubing it. So all into the calculator. If you don't remember how to put the cube in, you hit the little up symbol, which is right above the division symbol. That it means we're raising it to a power, and then you're going to hit 3 for raise it to the 3rd power. And I get 11,494.0 centimeters cubed. So in case you are wondering or don't remember how to put the fraction in the calculator, all you really need to do is hit the parenthesis sign, which is above the number 8. If it was 1/3, you hit 1, the division symbol, 3, close parentheses. Alright, now let's go over how they are used in real-world problems. So Jacob is using a cone-shaped figure to fill a ball with water. The ball has a diameter of 11 inches. The cone has a radius of 3 inches and a height of 8 inches. About how many times will he have to fill the cone to pour into the ball so that it is full? So first of all, I'm going to identify my question. So I want to know the number of times I have to fill the cone to fill the ball. So essentially, how many cones are going to fit into the ball? So since I have two shapes, first of all, I need to draw my shapes. In label, here's my cone. It tells me that the radius, so that's halfway, is 3, and the height is 8. Then I have my sphere. My sphere gives me the diameter, that is 11. So before I can even figure out how many times the cone fits into the ball with water, I need to first find the volume of each shape. So I'm always going to first write the original formula. So I'm going to write my formula and plug everything, 1/3 pi r. They give us the radius, so I don't have to do anything. And then times my height, which is 8. Plug everything into the calculator. And I'm going to go ahead and round to the nearest tenths place again, and I get 75.4 inches cubed. So that's how much water can fit into one cone. I'm going to do the same thing but with the sphere. So volume equals 4/3 pi r cubed. Now with this one, since they give us the diameter, in order to get the radius, I need to cut it in half. So 11 divided by 2 is 5.5 cubed. I'm going to plug everything into the calculator. Round to the nearest tenth, so I get 696.9 inches cubed. So I have the total amount of water that can fit into the sphere and the total amount of cones. So essentially I have to figure out what operation I need to do with these two. I'm not going to be using addition or subtraction because I'm not taking out anything, or I'm not looking to add the number of or the amount of water from the cone. I don't want to multiply because I have my total amount that I need to fill, and I'm not making it bigger. I'm not multiplying it by the number of cones. What I need to do is divide. I'm taking my total amount that I need to fill, and I'm breaking it up into the amount that is in a cone. I essentially want to find out how many cones fit into the sphere. I'm breaking the total amount of the sphere up into sections that are the amount for the cone. So when I divide that out, I get 9.2 cones. So I'm going to have to fill my cones up over 9 times in order to completely fill the ball. So I would have to fill it up at least a 10th time. Even though when I fill it up a 10th time, we won't use the whole amount, we'll only use 0.2 of it. So 9.2 cones will fit into the sphere. I need to fill it up 10 times actually though, in order to get the sphere completely full. Alright, and let's take a look at this one. It says the coffee can below is 2/3 full of coffee. About how many cubic inches of coffee are in the can? So first of all, I see I have a cylinder and I'm filling it, and it's a 3D object, so I'm going to go ahead and write my formula for a cylinder, pi r squared times height. Then I'm going to go ahead and find how much can fit into the whole cylinder. So I'm given my diameter because the 6.4 is all the way across. So I need to divide that in half, divide it by 2, and I get 3.2. Square it, and then I'm going to multiply it by its height. Again, I'm going to round to the nearest tenth, and I get 257.4 cubic inches can fit into the entire can. However, the can is not completely full. It's only 2/3 full. So I'm going to need to multiply my total amount, 257.4. I need to multiply it by 2/3. We have 2/3 of my total, which is 257. And I'm going to get 171.6 inches cubed is how much we actually get. Now, test taking strategy. If you were to actually divide these two numbers, you would get a number much larger than 257. So you should use reasonableness and realize that I should not be getting any number bigger than 257 because that is the total amount that the can can fit. It can't fit any more, and I know that it's not full, so I know my number needs to be less than 257. If you know how to solve it a different way and figure out the 2/3, then that is fine. We can do it multiple ways as long as you still get this answer.